So with these questions, sometimes you might be working in radians, as we see in this particular question here, or sometimes it might be in degrees. If it's in radians, make sure you've got it set in the radian mode, your calculator. That's very important. So check that your calculator is in radian mode. So let's take a look at this question here. It says here, first of all, find in centimeter squared the area of the sector BDE. There's BDE, it's referring to this area here. And this is using, remember, how we find the sector area, the formula for it. None of these you're given in a formula book, you need to know that. If you remember from GCSE that the area of a sector is essentially a fraction of the circle. Suppose this is theta, it's a fraction of the circle, so it's pi r squared, which is the full area, times theta over 360. Now if we're working in radians, it's pi r squared times theta over 360 in terms of radians is 2 pi, and so then this simplifies to half r squared theta. So this becomes the area of a sector in terms of radians, where theta is in radians. And this is really important, where theta is in radians. Okay. So if you use degrees here and you just substituted the angle in degrees, it wouldn't work. Because the whole point is, because I changed the 360 into radians, I was working with radians here. So very important to remember that. So go and work this out. You can actually work this out quite easy. So the area of that sector would be equal to half r squared, which we're given here, 5 squared, times theta, which is in radians, is 1.4. So that's part A of that question. So part B, that's part A. Part B then goes on to say, find the size of the angle DBC, given your answer in radians to 3 decimal places. So first of all, let's understand the angle that we're after, DBC. DBC, we're after this angle here. I'll put an X here, indicating that's what I'm trying to work out. So as you can see here, I've got a triangle here. The triangle DBC forms that angle X that we're trying to find out. And we actually know everything about this triangle. So let me go and highlight the triangle I'm looking at. It's this one here. And I know all 3 lengths of that. So I can actually think about, what do I know? What knowledge can I use? So I can use the cosine rule here, because I'm given 3 lengths and I'm trying to find the angle. So you'd go and use the cosine rule here. And remember, the cosine rule formula is a squared is equal to b squared plus c squared minus 2bc cos a, again not given to you. Remember, this is one whole term together, and we're trying to find out this angle. But we're working in radians, so make sure you've got your calculator in radian mode. What are a, b and c? Well, remember the angle here is a, so if you wanted to relabel your diagram, really this angle has to be matching that here. Okay. Can I use it instead of using ABC? Can I use the letters here, BDC? Yeah, you can in your formula. Or if it helps, it might be easier to relabel the diagram, if that helps, or just redraw that triangle. There you go. That'll probably be the easiest thing. Label that angle that we're trying to work out. I'm going to label that as A, and B and C will obviously be the other sides. Do we know everything about it? Yes, we do. I'm going to just rewrite it here, 7.5. These labels that I'm using ABC are ones that do not get used with this. For this, the formula that I normally use here, and so then you would go and use that appropriate formula. Okay, and when you get the angle, I mean, there's places where students make mistakes with this. It's obviously GCSE knowledge, this here, cosine rule applying, but where mistakes are made is this bit here. I'll just show you here. 6.1 squared. I'm going to write everything in here. 7.5 squared plus 5 squared minus 2, 7.5, 5, cos x. And so when we rearrange this, this is the mistake that's often made. Students will work this all out together. They'll do 7.5 squared plus 5 squared minus 2 times 7.5 times 5 to simplify that. Can you see what the mistake is there? Anyone write down what the mistake is? So we've essentially, if we type that all in the calculator, students simplify that and they get a number, and they then write down that number and then write down cos x. What's the mistake there? Anyone write it in? Sure. Have a look, spot the mistake. Common misconception there. Anyone? Yeah, thank you, Umar. The minus 2 times 7.5 times 5 is multiplying the cos, and so that's a term associated with the cos term. It's not just a number term, so that's where the common misconception is. So here, this bit here is not just a number, is it? It's multiplying the cos x, so that's the whole term together. You can't add numbers with a term which has cos x's in it. So really what you would do is you'd do 6.1 squared. You can add these two up, that's fine. I would just minus that, minus the 5 squared is equal to minus 2 lots of all of that. So that's minus 2 times 5, which is 10, which is minus 75 cos x. So this is one term in its own. And so then to get rid of the minus 75, you would then divide both sides by minus 75 to get cos x. And then you can work out what x is. So just be careful with things like that. And then it goes on to say find the area of shape ABCDEA, which is referring to that whole shape. So what can we use? Well, you can use the area of a triangle, AB sine, where you know this angle, so that angle will be the C, and this will be your A and B. You can find the area of the sector, which you already found, and then the area of the triangle is essentially base times height divided by 2. You can apply that once you've got those things. How would you find the base height? Well, you'd probably have to do some right angle trigonometry, SOHCAHTOA, etc. Well, how can you do that when you don't have this angle? Well, you need to figure out the angle, because we know the angles around or on one side of the line is equal to pi in radians. And since we worked out what x is previously, we can work out what that final angle is. So then you can use that and this angle to work out these other lengths to then go and work out the area of that triangle. Okay, so it's all kind of trigonometry here, this stuff here. Triangle, right angles, sectors. But you've just got to be very careful with your working out. But it's a nice number of marks to get for this particular question.